Welcome to the module describing the functionality and use cases for GigaSMART load balancing. In this module, you will learn how GigaSMART is able to load balance traffic delivery to multiple tools. At the end of this module, you will be able to explain which situations benefit from load balancing of selected traffic, describe the options for stateless load balancing, describe the options for stateful load balancing, explain the load balancing resilience and reliability capabilities, and identify situations where load balancing would improve monitoring and security. Monitoring traffic for planning, troubleshooting, and security purposes rarely involves packets for just one link. Even for just one monitoring task, you are usually looking at packets on all of the links that go there. However, when even a single link is monitored, there is the potential for double the traffic volume. Consider the link diagram below, where a link between a web server and the nearest switch has been tapped. The link is bidirectional. Thus, a 10 gigabit link could carry up to 20 gigabits of traffic. A simple check of the performance for common types of tools suggests that complete deep packet inspection is reliably performed for somewhere between 2 and 6 gigabits of traffic by a single dedicated appliance. Larger multi-core appliances are able to perform better, but many tools still cannot analyze a full 10 gigabit link. Thus, whether there is a single link or many aggregated links that require monitoring, it is quite common for the traffic inspection task to require the packet stream to be divided between two or more tools. GigaSMART load balancing is somewhat similar to a GigaStream load sharing. Both divide and distribute traffic among tool ports in a logical grouping. With GigaSMART load balancing, you can include any port in the node as a member of the tool group, instead of any port on the same line card. You can even include ports operating at different speeds. To accommodate the bandwidth differences or to accommodate the processing capabilities of the attached tools, you can weight delivery of traffic on a per-port basis. One configuration option for GigaSMART load balancing is able to use the same hashing algorithms which GigaStream load sharing uses. However, GigaSMART can also match and load balance based on inner addressing within encapsulated and tunneled packets, such as GTP, GRE, and ER-span. GigaSMART can even perform stateful load balancing for GTP tunneled traffic and load balance the sessions from ASF session-based filtering. Stateful load balancing support extends to a variety of traditional load balancing options, basing new flow distribution on packet rate, connection count, or even simple round robin. Stateful load balancing distributes new sessions for GTP tunneled traffic to multiple tools based upon hashing of a selected metric. For each new session, a tool port is selected from the available port list based on the hashing of a subscriber ID field. Either IMSI, IMEI, or MSISDN may be configured as the subscriber ID used for the hash. For the other metrics related to port loading, port weighing, or sequential session assignment, new sessions are identified by the IMSI subscriber ID and assigned according to the metric. In order for traffic analysis to be effective, load balancing always sends traffic for a given subscriber to the same tool port. Because GTP-C control traffic is important for understanding the GTP traffic flows, load balancing can be configured to replicate GTP-C packets to all ports in the port group. Sessions identified by the application session filtering feature can also be load balanced so that the entire session is delivered to a single tool. Since it is important to ensure that all packets are delivered for inspection, GigaSMART load balancing also supports traffic redistribution based on detected port failure or port failure recovery within the group of load balanced tool ports. If link goes down for one of the ports in a GigaSMART port group, then traffic for the down port is immediately and automatically reassigned to other ports in the port group. If a port returns to service, that port is added to the pool of available ports from which one will be selected and the next new session will be assigned. If stateful load balancing produces a larger than expected traffic stream, then there are safety configurations that can move traffic to less utilized ports to ensure that packets are not dropped. When failover is enabled, then the failover threshold setting is considered with the configurations of least bandwidth and least packet rate. When a port is over threshold, then the algorithm will move a session assignment to a new port rather than continue sending traffic to an over threshold port. The GigaSMART load balancing options are included with almost all of the other GigaSMART features, excepting unrelated operations such as net flow generation. Use load balancing to improve most monitoring and security environments. Here is a quick review of some of the common network situations which GigaSMART load balancing can assist with or resolve. Probably the most common problem experienced is when a tool is asked to perform more deep packet inspection than it is capable of. As the complexity of networking and the range of security risks continues to broaden, this challenge eventually overcomes even the best tools. The solution is simple and easy. Just divide the traffic between enough like tools so there is adequate processing capacity to fully analyze every packet. A related problem is found as deployments grow. Newer tools have more processing capacity than older tools, but all of the tools do the same job. In this case, after dividing the traffic, then wait packet delivery so that the capabilities of each tool are accounted for. Networks are upgraded to meet increasing demand. That also means that the various monitoring and security tools may have different speed interfaces. Use delivery waiting to account for port speed, just like accounting for processing ability. Most larger networks include remote sites and other architectures requiring various encapsulations or tunnels. Use inner-encapsulated packet addressing as the basis of load balancing rather than the outer tunnel or outer packet addressing. Mobile service providers tunnel subscriber activity through GTP routinely, but are intensely interested in ensuring performance for individual subscribers or groups of subscribers based on subscriber prefix. Use subscriber ID fields as the basis for load balancing instead of simply distributing GTP tunnel traffic. Regardless of how good anything is, the odd problem will eventually take place. Should one of the tools in a load balance group fail or be taken out of service, the load balancing algorithm will automatically redistribute traffic which had been going to that failed tool. The other tools in the group will take over inspection of that traffic. Hashed traffic is automatically rebalanced. Similarly, when the failed tool is returned to service, if hashing is used, it is returned to the pool and traffic is rebalanced to again include the recovered tool. If using a traditional load balancing configuration, the load balancing algorithm will automatically put that returning tool back into the pool of available tools. And for capacity-based configurations, it will be preferred so that new sessions will be directed to the return tool until the workload is approximately balanced again. The volume of traffic which requires monitoring and security attention is expanding at unprecedented rates. Almost the only economical way to accommodate the volume of traffic is to centralize tools and to send only the appropriate traffic to each specialized type of tool. That means growing the pool of tools receiving each type of traffic to meet demand and sharing the inspection load among like tools. Since security-related analysis often depends on session-based activity, using GigaSMART stateful load balancing configurations for packet delivery enhances the GigaSecure Secure Delivery Platform, the industry's first security delivery platform. For those and other situations, the GigaSMART weighted packet distribution can help older and newer tools to work together for as long as they are still viable. For more information, refer to the GigaSecure training module. Additional details about GigaSMART load balancing are in the training modules for the same, and for GTP correlation, adaptive packet filtering, and application session filtering configuration, the GigaSecure training module, as well as the HView web interface online help topics. Other information is available from the GigaSMART datasheet and brochure and in the user guides. In this module, you have learned how GigaSMART is able to load balance traffic delivery to multiple tools. You are now able to explain which situations benefit from load balancing of selected traffic, describe the options for stateless load balancing, describe the options for stateful load balancing, explain the load balancing resilience and reliability capabilities, and identify situations where load balancing would improve monitoring and security. This completes the GigaSMART load balancing training module. Thank you.